Recall that sine and cosine have period of 2 pi. Since cosecant with this notation and secant with this notation are the reciprocals of sine and cosine respectively, they also have a period of 2 pi. So cosecant of x plus 2 pi is just cosecant, and secant of x plus 2 pi is just secant. However, tangent with this notation and cotangent with this notation have a period of pi. So tangent of x plus pi is equal to tangent, and cotangent of x plus pi is equal to cotangent. With these functions, you have to be aware of the fact that there exist vertical asymptotes at regular intervals throughout these 4 trig functions. From the graphs below, you can see the shape of each function and where their asymptotes are normally located. So first, we're going to look at the function y equals cosecant x that has this shape, little bumps on the top and bottom, above and below the x-axis, and vertical asymptotes every pi interval. So you can see we have one at negative pi, at 0, at pi, then at 2 pi, and so on. So every pi on the x-axis, you will have another vertical asymptote going on forever. Next, we have the function y equals secant x, and you can see it has a similar shape, little bumps above and below the x-axis, just a little bit different spot, and it has vertical asymptotes at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so on. Every pi along the x-axis after one asymptote, you will find another asymptote. Here we have the graph of y equals tangent x that has this basic shape running from bottom to top in between each of the asymptotes. And you see the asymptotes occur at regular intervals every pi along the x-axis. So we have negative 3 pi over 2, then negative pi over 2, then pi over 2, 3 pi over 2, and so on. So every pi increment after an asymptote, you'll find another asymptote. And then last we have y equals cotangent x, which has a similar shape except it's running from top to bottom. And you have asymptotes at every pi increment. So negative pi, 0, pi, 2 pi, and so on. So after every asymptote, you go pi distance down the x-axis, you'll find another asymptote. And those are the graphs of the 4 trig functions: cotangent, tangent, secant, and cosecant. Now, the basic equations for these trig functions are a little bit different each, but still has some of the same basic form. So we're going to start off with cosecant and secant, where they are not shifted. So for a cosecant or secant function that has no shifts, their respective equations are y equals a cosecant kx and y equals a secant kx, where k is positive. And again, there's a period every 2 pi over k. Now, an appropriate interval on which to graph one complete period is typically 0 to 2 pi over k for these two functions. Now, for tangent and cotangent, again not being shifted, for a tangent or cotangent function that has no shifts, their respective equations are y equals a tangent kx and y equals a cotangent kx. Again, k is positive, and they have a period every pi over k. Now, to sketch a complete period of these two graphs, it's convenient to select an interval between the vertical asymptotes. And since they're a little bit different, there's 2 different kinds of intervals you should use. For tangent, an appropriate interval is between negative pi over 2k and pi over 2k. And for cotangent, an appropriate interval is 0 to pi over k. So it's a little bit different for each one. But to graph it, just one period is sufficient. Now for the graphs that they're shifted, what would their functions look like? We're going to start off with cosecant, which would be a cosecant of k times the quantity x minus b, and then plus d. And secant is a secant times or of k times the quantity x minus b plus d. Again, k is positive. The period is just 2 pi over k, and the phase or horizontal shift is B, and the vertical shift is D. For tangent and cotangent, again, they're fairly similar. A tangent of x times the quantity x minus b, then plus d, and then for cotangent, it's a cotangent of k times the quantity x minus b plus d. And this has a period of pi over k, a phase or horizontal shift of b, and a vertical shift, that is d.